I welcome you also. Glad you could join us this morning. And we hope that this webinar brings you a positive end to what's already been a great week. So let's move on, see what we can learn today. Again, Fridays on the Farm. We do this every week, and you can look on the Organic Farm Team website to see the schedule, as May has already introduced. Today's talk will be on fertility in organic systems. We'll take a moment and introduce our Organic Farm Team concept. I'm assuming you didn't go through this already, May. I missed that little bit.
No,
Okay.
yeah, go for it.
All right. Well, we are a team with multiple divisions, or divided responsibilities, and we have a lot to offer for organic growers and transitional growers, and we're not confined to that, but that's where our main focus is in the organic realm. My talk this morning, Alan and I will discuss the organic improved inputs slice of this pie. And you might be wondering who all the characters are that are part of this team. And there you can put some names to some faces. We're here to help, and you see a bunch of smiling faces there, and we'd love to hear from you, visit your farm, whatever it is that you might need. So I've lived in Nebraska for about 13 years now, born and raised in New Jersey, wasn't involved in agriculture at all, really, except for a big garden in the backyard. Even though while growing up, when the wind was right, we could smell the silage and other fragrances, I'll say, from what I believe was the most innovative dairy farm in the country. I really got my start in agriculture with a summer job during college when I worked at American Cyanamids research farm in Princeton, my hometown. And then the following year, I worked for leach aerial applicators in the San Luis Valley, Colorado, scouting fields, working primarily with malting barley, potatoes, and lettuce. So that was sort of a broad slice of agriculture to jump right into in my early years, and I learned a tremendous amount from that. Rather than dwelling on the past, I'm excited to look toward the future here, and it's exciting to be working with a team that works with organic growers, and our focus really is to bring you a harvest that will be just an absolute top quality product, top quality crop, and from start to finish, from the seed clear through to the marketing. So we're really all about helping you to be the best that you can possibly be, and we'd be real happy to be part of your team. Alan Dale, who is with our affiliate Douglas Plant Health, will be joining us in a bit after my presentation. I will go over some more general concepts, and he'll get into some specifics. And as I go along, as he and I both go along, please feel free to jump in with questions if you have them, and we'll try to keep this short enough that we have plenty of time for a good discussion afterwards. So I'll begin with some more general principles, as I say, and kind of breaking down the science behind the biology of what we're doing. Let me get something out of the way here on my screen so I can see what you're looking at too. Okay. And we need to ask questions. We need to ask, what are we doing? Why are we doing it? And what do we expect to accomplish with our efforts? And as we go through that process, that will help us to understand the science behind what we're doing and how to apply our various management practices. So soil health, we've all heard the term 1,000 times, and soil health implies that the soil is alive, right? It's a lot more than just sand, silt, and clay particles and a physical medium that holds roots in place and keeps your corn from blowing over. here's just a quick overview of a lot of the different life forms that are found in the soil, from the primarily microscopic in the left-hand column to mostly things that you can see with your eyes, except maybe for the largest of nematodes. The smaller nematodes you need a microscope for. And then at the bottom, you've got the larger organisms such as burrowing rodents. All of these live in soil and all have a positive impact on the soil. And I need to qualify that because a lot of us see that word nematodes and we're thinking like, root knot nematodes and that sort of thing. Virtually all of these categories of creatures are diverse enough that there are beneficials. Those are the ones that we want to promote. Obviously, there are also various ones that could be parasitic or even predatory. So, nematodes, for instance, there are loads of good nematodes in your soil. In fact, the vast majority of nematodes everywhere are beneficial. And if we keep the soil healthy, we're going to have a preponderance of the beneficial ones. And some of those beneficials are directly beneficial to a plant, perhaps, and indirectly, certainly by preying on the bad guys, on the plant parasitic nematodes. So the diversity is just incredible. As we look at this list, that's a lot of creatures when you figure these are just broad categories and there are hundreds or thousands of species in each one, perhaps, for each category, perhaps. And for sheer numbers, it's kind of mind-boggling, but if you look at the bacteria, for instance, a teaspoon of soil could easily contain up to 1 billion individual bacteria. So the soil is indeed alive. That's just pretty overwhelming to even think about, and researchers readily admit, the top researchers readily admit, we barely even scratched the surface of a complete understanding of this. So soil health and basic life requirements are what we want to look at here. If the soil is healthy, it's loaded with living organisms, more than just plant roots, as we just saw. And they're really no different than you and I. We need air, we need moisture, we need temperature, and we need food in order to survive and to be healthy. And if any one of those factors are eliminated from our life or from the life of the environment of these little microbes in the soil, if any single one is eliminated, we die. If any one of those is compromised, then we live to then we don't fulfill our potential. So we live in a less than optimally productive state. So we want to pay attention to all of these: air, moisture, temperature, and food. And the one thing that's pretty typically not mentioned when we talk about soil health is shelter. That's important too. And shelter, for the preponderance of life in the soil that we're concerned with, is going to benefit from an improved soil texture. And soil texture is going to be helpful, but the way the soil particles within that textural profile come together in aggregation, that's going to provide shelter for the smaller microbes. Other aspects of the shelter in a bigger sense could be the canopy, the crop canopy, to shade the soil to keep it from getting too hot. A litter layer on the soil, plant residue layer, also insulating the soil from too much heat, insulating it from rapid changes in moisture, or even preventing that surface from drying out. So all of these things impact the quality of the environment where we want to be promoting optimal biological activity. And in varying degrees, our management practice are going to impact all 5 of these aspects of the soil. Pardon me. Management practices that might include cover crops, our tillage, the way we irrigate, all of these things, the way we till, the way we prepare the soil, and the way we manage it through the process of growing a crop. So everything we do out in the field is going to impact the quality of that environment for our microbes, and we really want to be promoting them. So how do all these organisms work for us? Well, let's look at what might have been a biology class for you back in maybe 7th grade, when we looked at what were called trophic levels. They're the different levels of organisms in an ecosystem, because that soil really is an incredibly dynamic ecosystem that we want to keep in balance. Well, the first trophic system in any environment is the producers. The producers are defined by those organisms that gain their energy from sunlight. So obviously plants are the producers, primarily in most environments. Green algae also would be considered producers, and because they absorb sunlight and energy from the sun, and that's their energy source. So the next level would be the primary consumers. Primary consumers are defined by those organisms that eat the producers. It's kind of like the rabbit that comes in and eats your garden. That rabbit is a primary consumer. Secondary consumers are those organisms that eat the primary consumers. And if we keep on thinking about that little rabbit, then a hawk that comes along, or a fox that comes along to eat the rabbit, that's a secondary consumer. We can see that those sorts of things are around us every day. The same dynamic is occurring within your soil all the time. We don't see it, but it's going on. And we need to keep all of those things in balance, because ultimately what they do is, well, I left out one. All right, so we go through the first 3, then we get to the decomposers that eat both the producers and the consumers. And the decomposers mineralize nutrients. And what do? Those mineralized nutrients go back and feed the producers. So you can see there's a cycle here. And cycles are typically dynamic, right? And they're also sustainable. That's kind of a popular word these days. This is a truly sustainable system. But in an agricultural setting, we need to be careful with what we do to keep it sustainable. If we disrupt a part of the process, then we run into trouble. Pesticides can disrupt the process. Tillage can disrupt the process. Some of these things that we do, we kind of have to do, but they're temporary interruptions. But really gross assaults on the system are things that we want to avoid. So how do we accomplish good soil health, and how do we maintain that balance, that dynamic system that we just looked at? There are 5 principles of soil health. Some may say 4, others say 6, and I kind of took the middle of the road. In my biology classes in college, we used to talk about lumpers versus splitters. There's some people that want a few categories somewhere, and others that want lots of categories. Well, the lots of categories are typically just the fewer ones broken down even more finitely. We'll just stay with the 5. That works comfortably. So we want to minimize soil disturbance. We all understand that, and many have gone no-till, although that's a pretty big challenge in organic settings. We want to maximize soil cover. I already mentioned a little bit about that relative to providing safe shelter, a healthy sheltered environment for the microbes. Of course, that also, the maximized soil cover also provides shade and temperature regulation for the plant roots. And soil cover also, soil cover also is going to maintain an optimal cover, green cover, and the green is going to be absorbing sunlight, sun energy, which we'll get into in a little bit, and putting that back down into the soil. Increased crop diversity is really critical to an organic system, because that crop diversity is going to be taking that energy from the sun and putting it into different places in the soil depending on the crop. And as a for instance, or broadly, you can think that we have short season crops and we have long season crops. We have crops that are more active early in the season and others that are more active later in the season. We have crops that are deep rooted. We have crops that are shallow rooted. We have crops that are grasses, and we have crops that are broadleaves. All of these actually work a little differently than each other when it comes to taking that solar energy and where and how they place it in the soil. And there's some diversity in the microbes that live on the roots of those crops. And the microbes all benefit from the solar energy being transformed into sugars exuded through the roots and feeding the microbes. So there's a little broader explanation of how important crop diversity is, not to mention the the benefits of weed control and weed disturbance and those sorts of things. But that's kind of a little outside of today's discussion. So we really want to keep living roots in the soil all the time, and for the reasons stated, the living roots in the soil are going to be attached to that energy absorbing aerial portion of the plant, and those roots will be transferring energy into the soil. And we can't lose track of energy. Every system is driven by energy. It doesn't matter if we're talking about you and me, if we're talking about our tractors, energy, or a factory, anything in between. Energy drives those systems. And in the field, the energy comes from the sun through the plants into the soil. So the energy feeds the microbes, and the microbes in turn take the nutrients from the soil and feed the plants. There's another cycle. So if the plant can feed the microbes well, then the microbes can feed the plants well. And the fifth principle is integrating livestock, because they complete this whole system. Through they're both consumers, and they're also the decomposers. They're consuming the plant matter, live plant matter typically, unless you're feeding them hay or you're grazing them after the growing season. You're grazing residue. But in any case, they're primary consumers and producers rather, and the recycling part, the decomposer part, is because an awful lot of material goes through them and comes out the back end as a mostly decomposed product. If you look at these three that are in the middle, they're really involved in harnessing solar energy, and I really am emphatic about the energy part, as you have well sensed. we want to keep that going. I'm going to have to flip to something here for a moment. Okay, so should I stay on track? We have in the Platte, South Dakota area where we work out of, we've got, according to the records, 214 sunny days in a typical year. And to the extent that we can harness energy from the sun on those sunny days, you know, as long as there's not snow cover, any plant that survives the winter and has some green in it, even if it's somewhat frozen up, it's still going to be doing some level of photosynthesis and some level of absorbing energy and putting it into the soil. So obviously there are higher points and lower points in the year for that benefit, but we're going to that maximizing soil cover aspect of this, and as long as you can keep green on the soil cover over the soil, you're going to be harvesting benefit. Solar energy is free after all, so why not take advantage of it? Think of it kind of like installing solar panels for electricity. You know, you can install solar panels and you can see the benefit. You can turn on lights and so forth. There's a visible and a tangible benefit. We don't necessarily see that in the soil. In fact, we really don't unless we get really scientific about digging into it. But it's going on in a very big way. The solar energy is ultimately stored as sugars in the plants, and I suppose most of us are well acquainted with that. It bears repetition because of its significance, because the sugars are stored both in the crop, you know, the sugar and starch in your corn kernels, sugars in your grapes, sugars in anything that we grow. Are there any questions yet? I've just been running on and not asked for any questions.
Yeah, I haven't seen any come up in the chat box. If anyone has anything they're curious about so far, just let me know there and we'll keep on trucking.
Okay. So, let's see. And backing up a little bit, if we really want to get nerdy about the scientific end of all this, we could talk about the Krebs cycle, or we could talk about mitochondria in the cells, but that's really getting down to how energy is transformed from sunlight to the plant usable portion, and where that happens. The fact is that it does happen, and I will get a little bit nerdy on this one. If we think about the first law of thermodynamics, that says that energy is neither created nor destroyed, it just changes form. That's what we're doing. It's a pretty fundamental law of the natural world, is we're taking that soil or that sunlight, that sun energy, and transforming it into various forms that are beneficial for us. So we want to make management decisions based on the science behind the 5 principles of soil health. And this includes the application of biologicals, and that could include feeding existing, existing populations that are in the soil. And there will pretty much always be existing populations of beneficials in the soil. The question is how many and what type. So when we're considering what biologicals will be most beneficial for us, we want to think, are we seeking to feed the existing populations? Are we seeking to augment population numbers? And the feeding and the augmentation that kind of go together. Or we also might want to increase the numbers of things that might be already there, but just kind of give a jump start. And we want to think about when we need to do that, which we'll get into in a moment. We also might want to augment the population diversity. And that would be in a case where our soils are primarily bacterial and we want to put more fungi in there. That would be an easy example of augmenting population diversity. So, let's see, just lost my train of thought. Yes, we want to think about the timing for all these things also. Let's see if that's it. Yeah, so considerations when we're choosing these biologicals, more considerations would be the product we use could contain food, it could contain a live culture, it could be a biostimulant, it might be a formulation that has all three in there. And again, we want to look at what is it that we're trying to accomplish. Timing is real important when you're considering your biologicals. Generally, what we're seeking to do is maximize our nutrient availability, because that's what the biological, that's what the microbes, that's what the soil health aspect generally provides for us, is nutrient availability. So do we want to maximize that availability at germination? A good example would be in corn when the soil is still cool and we really want to jumpstart the phosphorus availability. You know, phosphorus, it takes a little while for that to become available to really get going, because the soil needs to be warm enough for the microbial population to be high enough to really have an impact. So we might want to push that a little early in the season for early benefit for our corn. Do we want to promote the vegetative, the top growth at some point in time? We might want to think about that in terms of getting our crop to canopy more quickly. That's a real big deal in organic systems, of course, because we want to shade the row middles and reduce weed pressure. You know, we might want to boost things during pollination. That's always a stress time for our crops, of course. And so to the extent we can maximize nutrient availability at that point in time, we're going to see a benefit. Or we might need to boost things during grain fill to give us higher test weight. So these are some of the considerations when we're choosing biologicals. Expectations, or some of the benefits for healthy soil. We want to have realistic expectations, and we want to have, but we will have expectations. That's of course the reason that we would consider applying a biological. That's why we put down fertilizer. That's why we buy a certain kind of seed. We have expectations. So some of the benefits, of course, are soil tilth and other physical qualities. Alan will address that in some detail in his presentation. We want to increase nutrient availability. Now, these things you all know, these are things that can happen, but what is it that we really want to focus on? And that's why I put this under expectations. Where are we looking to go with when we decide we want to use a biological? We want to decrease nutrient loss from erosion and leaching. We want to improve plant health. You know, what are these? Which one of these is key to a key challenge that we have that we want to improve? We might be looking at improving the crop health and the nutrient value. We might, with that, want to look at a biological that grows up inside the plant and fights pathogens and fights external insect pests as well. We have things to offer in these realms, and increasing the nutrient value too. If we can get something inside the plant that is going to reduce mycopathogens or mycotoxins in the seed, we're going to have a better quality, better quality of harvest and a more saleable harvest. We can do all these things for you. And it all sums up into increasing your crop quality and marketability. And going back to the soil, we really want to take care of the soil in an aspect that we don't necessarily see the immediate results, but the benefits are huge, and that's maintaining the legacy of sustainable productivity. We want to be improving our soil quality constantly. That should be always on our minds, no matter what we do. And that not only will benefit your operation today, this year, next year, but for years to come and even generations to come. Well, so with that, we will move over to Alan Dale's presentation, and he'll get into some specifics. So Alan's an agronomist. He works with Douglas Plant Health, one of our affiliates, and he's well experienced with his small grain forage and cow-calf operation, no-till for 25 years. That's significant. And he's learned a lot, and he can share those things with us and benefit all of our growers. He has a humus and a compost operation in Illinois, taking manure and other plant and animal wastes and transforming them into more crop available and more easily applied materials or end products is a tremendous benefit that he helps many people with, and he's helping us, and we it's just a valuable resource that we have in Alan and that experience that he has, and he works with clients throughout the area where we work. So with that, Alan, I think I just went too far. Let me back up there, and Alan, I'll turn it over to you.
All right, thank you, Drew. Thank you, May. Privileged to be with you today. Drew highlighted some of my background, and I do farm in north central Illinois. And for everybody that thinks that Illinois is flat and black, that's not what I farm. I can relate to soil types that most of you have. A lot of what I've learned from no-till about soil health and tilth and weeds. And I've tried to come today to share experiences with you, and that's where we're going to start. Next slide.
All right, sorry about that. I got to skip down a little bit. Oh, you know what?
Okay, I'll just keep going.
You keep going. I'm going to have to switch over.
Yep. The first slide that's going to come up here is if you want to make small changes in your farm, change the things you do. If you want to make major changes in your farm, it's got to change the way we see things. I start all my presentations with that. It's as much about attitude as anything. Biology, there's no silver bullet. It's a system of things in everything I've seen. There are about 10 factors that I was going to allude to in the second slide that all impact soil tilth. I'm going to focus a little bit on that area today, as opposed to trying to go to a broader subject of a number of biologicals. In 19, I know that South Dakota had nearly 4 million acres of prevented plant. I can relate to that. Illinois had 1.5 million, and we had 1,700 ourselves. So what happens when you get prevented plant? Obviously, we've lost oxygen. We've had some compaction occur. We don't have any oxygen in the soil. Can we regenerate that? Can we improve it? Can we salvage it? What's it going to take? I'm going to talk a little bit about manure. Manure can be a real asset, but we also need to understand the challenges it presents in a number of facets. In any given year, when you put together a plan for your crops, about half of the half of the value of that manure becomes available in the first year. And of that, only about a third is available to the current crop once it is mineralized. You're going to lose some to volatilization, some to leaching, and the other half pretty much the same numbers in the second year. The point of all this is, though, the higher the CN ratio, particularly in those dry manures of yours, the less percent nitrogen is available to the crop. You're trying to decompose material, you're trying to feed microbes, and that's why when that corn comes up 1, 2, 3, 4 inches and it's a light green, you're probably short of N and you're going to need some soluble N there to feed that crop. Next. So as we have that breakdown, we've got large amounts of CO2 and methane and ethylene and a number of things that is changing that soil, and it's not the direction we want to go. It's promoting an anaerobic condition. It's beneficial to weed seed germination. Many times it will trigger a weed seed to germinate. It's detrimental to the crop seed. There is microbial life present in manure, but much of it is anaerobic. Next. Tilth and organic matter are two different things. Obviously, we all want to increase organic matter, and it's amazing what 1% will do. I'm sure most of you know these numbers. Perhaps you're not as familiar with the one on the right as to what we can store in an acre of soil for the dry times. So what can we do to improve soil tilth? Next. How can we make a discernible change in it? Next. We have developed a solution to this primarily aimed at the manure challenges, but for any residue, be it wheat stubble, anything like that. Our MT17, we're attempting to change the environment of the soil to make it more favorable to the crop and less to the weeds. It is a biological. Next. We have to have 5 things occurring when we want to make this successful. Again, there is no silver bullet. We've got to have a lot of things interact. First of all, the biological is the product. We need active calcium. We can't rely on your soil test for what it says the level of calcium in there, because not all of it may be available to the crop. In a perfect world, you need to add another test to your arsenal. You will have to pay for it additionally and request it for water-soluble extract of calcium. In a perfect world, it'd be great to see that number at 300. That's unlikely to happen, but I need you to start pointing towards 200 and try to get a little north of that if we can, because what we're doing is taking that active calcium and putting it with that abundant carbon and making a huge reaction, a very specific one where we're combining those two and then introducing the microbials also. It's helpful to have moist soils. Irrigation is the best of all worlds, but a half an inch of rain is great. And while we can put MT17 into the manure stream anytime during the year, it is best in my mind if we can do it in warming temperatures. For those of us in the upper Midwest, that means spring. That doesn't quite apply so much to the southern US, but we're also using this product to a great extent in the panhandle of Texas and doing some tremendous things down there in the high plains. Next. So some may not be familiar with the term flocculation, but look at it this way, with the tips of my fingers being particles of soil distributed and dispersed throughout the soil. And at first glance, you think, well, that's great. We've got a nice medium all the way across, but what that tells me is there's no structure there. And so what we're trying to do with calcium, carbon, and MT17 is to take those particles and draw them together, and we call that flocculating. And the other part about that flocculation is within those small particles that have joined, that is where we can store that extra 10,000 gallons of water to get us through the dry times. And then once we have the flocculated particles there, they come together to make soil aggregates. We're trying to create structure and stabilize the carbon that is within the soil. When you smell manure, you're not only noticing an odor that's going up, you've got carbon going up, you've got nitrogen going up, you've got other minerals, And folks, those are dollars. We're trying to capture value. Next.
This is the last slide I
Okay,
have for the
very good.
presentation you sent me,
Now,
but we did have a question come up
excellent.
if you think you're done sharing.
I am done sharing. I went through that pretty quickly, so we had time for questions.
Sure. We had someone ask, kind of your thoughts on some of these products that include blood and feather meal. I imagine, they can influence the biology similarly to some of the manure we're talking about, but, I've been seeing more of these products in like a pelletized form out there as well. So I'm curious, if you have some thoughts on that.
I'll take a couple. While I haven't done specific research on them, anytime that I share with you or anybody, I'm only going to go from the points of my experience. But I will touch on the point of the pelletized part. There are many that proclaim that those pelletized parts contain microbes and significant microbial life. And I would challenge that with the fact that what I've learned from my humus compost operation, where we produce really high quality things, and it's all about microbes. Anytime in any fashion you compress microbes, you sacrifice them. And so I would ask you to consider that you may not have the microbial life that you have. And I think that's where I'll end that question. Is there another one?
Not right now. I just appreciated your response to that because, I think the poultry industry is kind of discovering that there's a lot of dollars to be made with organic approved inputs that can include blood and feather meal. So, it's always good to be a little bit skeptical. And that was, my hope in our webinar today is just helping folks understand, what are the right questions to ask when you're exploring some of these inputs.
And I did not mean to be skeptical of those two products, but my comment was I haven't experimented with them. And
Sure.
There are too many people that try to come across as experts about things they really haven't put into field research. And that's why I made the comment the way I did.
And if there's other folks on the call who have experience with this type of input, please chime in and share your experience if you like. I think part of that question on, the value of, blood and feather meal type products would be, maybe if they're not going to be the best thing for microbial life, are they helpful at least in that journey just to get your basic NPK? And I would assume the answer is yes to that, they'll deliver some of that basic, NPK needs, but then, balancing some of that with, microbial life and soil health is sort of the underlying goal. So how does that kind of make sense?
You brought the word up about balance, and that's what it's all about in all of this. We're trying to balance air and water. We're trying to balance how we're taking care of crop residue. We're trying to balance the fertility side of it. And it truly is a system solution. In my work that I do with several hundred farmers across the Midwest, the first thing I want to do is I want to walk on their soil and dig a hole. And we're going to start with a penetrometer. And the reason we want to use that is we want to get a baseline for how tough those soil conditions are. Without that penetrometer, we can't tell if we've made improvement. We can tell generally, but not specifically. And then I usually make the farmer dig the hole too. And so he can see how hard that is and where he hits it. And then if we have the privilege and the time, I want him to take his backhoe out there and do a soil pit. Now, what the heck does all this have to do with biology? We all know that that's where it is. I'm not nearly as interested, although it has its place, obviously, in what's above the ground. I want to know what's going on below the ground. And so that's where I start this biological journey.
Yeah, I like that kind of bigger picture view. And, one of the questions I love to bring up is, we talked about the value of cover crops a little bit today in, feeding our soil biology. And one of my favorite studies that I've seen on the benefits of cover crops for that showed oats as one of the premier annual crops we can plant to stimulate arbuscular mycorrhizal fungi, or mycorrhizal fungi, which has, you know, become a big point of discussion in the soil health world. And, you know, sometimes you can think to yourself, well, I can just grow something like oats and feed my biology that way. But, you know, with some of Drew's points earlier today, it really made me realize, like, you know, is the timing of the oats and how they enhance or feed mycorrhizal fungi, is that going to fit your crop need? So I think that's an interesting conversation as well in here.
Drew, can you bring up my third slide?
I can, Alan, just
Oh,
to
can you,
I'll do
Pat,
that.
sit on
with
the
my cover crop pictures?
Mm-hmm.
Please, be timely right now.
All right. Are you able to see that?
There we go. This was earlier in the presentation. This is part of the prevented plant in north central Illinois. This happens to be ground around my compost site. It finally dried off. I said that we didn't get any crop off of it. We finally got in the 1st of August. And what you see on the left is radish, turnips, and oats, where we've chopped it off. On the right is radish, turnips, and rye. Again, we chopped it off. Prevented plant not only affected row crops, it affected pastures and forages and all those things. And as I alluded, I've got a small cow-calf herd. We ran out of feed. So I was out there chopping that before I wanted to, but the soil tilth changes were immaculate. The one in the center happens to be oats and triticale. You just mentioned oats. And we chopped quite a little feed off of that too. And it was amazing what it did in terms of getting that soil back so we could get some oxygen in it, so we could create some tilth. And above all, these cover crops will capture substantial nutrients. I know there's a lot of debate across the country of whether this pays or not. Folks, we can't look at anything in a 1-year window. It's greater than that. Biology may not show its head much in the first year. It takes a series of things to happen. But after 2 or 3 years, you'll finally reap those benefits. You'll be able to see them. You'll be able to measure them. And I'm a big proponent of cover crops.
Thanks, Alan. I'm glad that kind of tied into your presentation there. And Drew, if you have any kind of final thoughts, we'll get wrapped up here in just a minute.
Well, just one point on the blood and feather meal, and that is it's been around a long time. And early in my career, I was very involved with horticulture and landscape things. And so for many decades, those materials have been around, typically used on a smaller scale, and they definitely have value. They do contain NP and K. So the bottom line is to just look at their fertilizer value and compare that to other materials that you might have available. And I agree absolutely with you, Alan, that the biology side of them, it just isn't there.
And if I might add one comment, before any of those things take place, the top 3 things to do on my list are, if they're applicable to you, first is address your drainage. Second is, while I'm a no-tiller, there are a couple tools and proper timing and depths where we can do something about compaction. And the third thing is look at pH, and then we're ready to go with biology.
Well, I just wanted to quickly share how to contact us here. We have time for another question or two if any folks got really inspired by the last couple minutes of our discussion here. Thanks again, everybody, for coming out. Here you have contact info for myself, Drew, as well as Herb Hazenkamp. Drew, if you want to type in your phone number in the chat box, just to make sure folks have that as well. I wasn't able to get that in here really quick. And I just wanted to share too that next week, we also are going to have a webinar. I didn't have time to throw it up on this slide here, but we're going to be talking about weed control, innovative strategies for weed control in organic and regenerative systems. So same time, same place, same link next week. We do post the recordings of all of these series on our YouTube page, Organic Farm Team. And you can also find information on, we have a summit event coming up here, March 5th and 6th, kind of coming up here pretty quick. You can see our entire agenda, figure out how to register, and just see updates online at our organicfarmteam.com. Or just give us a call if you have questions about that event at all. We're really excited about the agenda. We're going to have a lot of panel discussions with both growers and people from the public and private sector parts of the ag and organic industry. So please join us. We'll have virtual and live attendance. And I did just find out last week, we're renting out not only the entire community center in Platte, South Dakota, but we're renting out the entire bowling alley. So if you want to bowl with us, that's an option too. And I'll actually let you, I know you guys have a meeting coming up here pretty soon as well. I'll let you mention something about that as well here. I'll ask him to unmute.
Sorry about that.
Yeah, go ahead.
Coming up next Thursday in Cedar Falls, Iowa at the Hilton there, we're going to have an all-day seminar with some remote professors, people that I work with and associate with that have got 30 years of training in biology and organics and that. It's a wealth of information. There's no cost. Come on out and see us.
Wonderful. And I think with that, we're going to try to end relatively on time here today. Thanks again so much, everybody, for joining us. We really just enjoy having conversations and learning together. So reach out to us with questions and maybe we'll see you next week.
Thank you.